Let's take a quantitative approach to main sequence lifetimes. The symbol for main sequence lifetime is a little t, that's for time. Please make sure it's a little t because we're using big T, capital T for temperature. And we have our subscript ms, that's the main sequence lifetime of the star. And main sequence lifetime is defined as the time that a star can keep up fusing hydrogen in its core and balancing itself in the state we call hydrostatic equilibrium before it runs out of hydrogen in the core and core fusion ceases. The relationship is actually quite simple because, as I mentioned in the last video, it depends entirely on the mass of the star. And so we have really only two variables in here, time and mass. And so the time, the main sequence lifetime of a star is going to be equal to the main sequence lifetime of the sun. Why do we have to put that in? Because we're using masses in solar masses, comparing it to the sun. So twice the mass of the sun, 4 times the mass of the sun. We're not going to worry about masses in kilograms. All the masses that I give you here will be in solar masses. This symbol means the sun. So the main sequence lifetime of the star is equal to the main sequence lifetime of the sun divided by the mass of the star to the exponent 2.5. Notice mass is in the denominator here because there's an inverse relationship with main sequence lifetime. The greater the mass, the less the main sequence lifetime. The main sequence lifetime of the sun is 10 billion years, as I mentioned earlier. That's 10 to the 10 years. 10 to the 9 is a billion, 10 to the 10 is 10 billion. So let's look at one example, which should be enough of how this works. How long will a 4 solar mass star live? Remember earlier when we talked about doing word problems that it's really important to make sure you know what you're working with, what you're trying to find, and not to panic. Take a nice orderly approach. And the first thing I said to you was to underline any numbers that you have. We only have one number in this question. Let's underline it and then figure out what it is and label it. So we have 4 solar mass star. This 4 is representing solar masses. What's the symbol for mass of a star? It's a capital M, so we can label it. What are we trying to find here? This is what we're trying to find. How long will the star live? So we'll circle that and we'll label it. How long will it live? That's the main sequence lifetime we're talking about. The symbol for main sequence lifetime is little tms. So we can write out our givens. We have the mass of the star is 4 solar masses. Remember, this symbol is solar masses. We're going to need another number. We need the number, the main sequence lifetime of the sun. That's going to be the same for in every question, 10 to the 10 years. And then we're looking for the main sequence lifetime of the star. So now we know what we're doing. We're trying to find TMS. What formula do we have for TMS that involves M and the main sequence lifetime of the sun? This is our formula. TMS equals solar main sequence lifetime of the sun divided by the mass of the star to the exponent 2.5. Now remember, you could then write out your equal signs in a line here and put down your units for your answer, which will be in years. Main sequence lifetimes are in years. I'm going to go ahead and do the substitutions. What's the main sequence lifetime of the sun? It's 10 to the 10 years, so that's going to go in there. What's the mass of the star? It's 4, so that's going to go in there. I do my substitution, and then I'm simply going to punch the numbers in on the calculator. 10 to the 10, 4 to the exponent 2.5, and the answer I come out with is 3.10 times 10 to the 8 years. If you want to, you could stop there, or we can put this in a more meaningful way by using words. 3.1 times 10 to the 8. 3.1, if we move that, we get to 310 times 10 to the 6, and 10 to the 6 is a million. So this is actually 310 million years. That's pretty amazing. The sun will survive fusing hydrogen in hydrostatic equilibrium in a nice balanced state for 10 billion years. If you start off, if you have a star with just 4 times that mass, its main sequence lifetime is down to 310 million years. So mass, again, size really counts. So you have a worksheet with some practice questions to do. What we'll look at in the next lesson is what happens after the main sequence. What happens when a star runs out of core hydrogen?